Inverse trig functions. When using a calculator to find the missing side of a right-angled triangle, we can simply use an inverse trig function. For example, if we've got a triangle with sides 5 cm and 8 cm, and we want to find the angle theta, the first thing to do is label the sides of the triangle. And we see that the sine of theta is the opposite over the hypotenuse, which is 5/8. So we can take the inverse sine of 5/8, which is the inverse sine of 0.625, and that tells us theta is 38.7 degrees. Now, since theta lies between 0 and 90 degrees, it's one of the angles of the triangle, this is the correct answer. However, if theta can lie outside the range 0 to 90 degrees, it has many possible values. So how do we select the correct one? For the time being, we'll consider the case when all angles are measured in degrees. So let's look at the inverse sine of x. When using a calculator to find the inverse sine, it'll give an answer theta which lies in the range minus 90 degrees to 90 degrees. And this value theta is called the principal value. Now there is a second important value, which is 180 minus theta. And using these two values, we can add or subtract 360 degrees as many times as we want to find the other values of theta. As an example, if we take the inverse sine of 0.625, the principal value is 38.7 degrees. And the other value is 180 minus 38.7 degrees, which is 141.3 degrees. Now, all the other values, and there's an infinite number of them, are 38.7 plus or minus a multiple of 360 degrees, or 141.3 degrees plus or minus any multiple of 360 degrees. We can see some of these in the table below. If we look at the inverse cosine of x, when using a calculator to find the inverse cosine, it'll give an answer theta which lies between 0 and 180 degrees, and this is the principal value. Now, the second important value is minus theta. So we have two values, theta and minus theta, and we can add or subtract 360 degrees as many times as we want to find the other values of theta. As an example, let's find the inverse cosine of 0.5. Well, when we do that on a calculator, that gives us 60 degrees. So the principal value is 60 degrees. And we also have another important value, which is minus 60 degrees. So the possible values of the inverse cosine of 0.5 are 60 degrees plus or minus any multiple of 360 degrees, or minus 60 degrees plus or minus any multiple of 360 degrees. Some of those results are shown in the table below. If we want to find the inverse tangent of a number, then we can use our calculator, and this will give us an answer of theta lying between minus 90 degrees and plus 90 degrees. This is the principal value. We can get all the other values by adding or subtracting any multiple of 180 degrees. So, for example, if we want to find the inverse tangent of minus 1, we can do that on a calculator, and that gives us minus 45 degrees. This is the principal value. All the other values are minus 45 degrees plus or minus any multiple of 180 degrees. And we can see some of those examples in the table below. These are 405, minus 225, minus 45, 135, 415, 675, and so on. So when we're trying to find the inverse sine, when we do it on our calculator, we'll get a value theta naught, which is the principal value. The other important value is 180 minus theta naught. And then all the others will be theta naught plus n times 360 degrees, or 180 minus theta naught plus n times 360 degrees. If we're trying to find the inverse cosine of x, then we have theta is equal to plus or minus theta naught plus n times 360 degrees. And if we want to find the inverse tangent, then we get the principal value theta naught and we add on n times 180 degrees. Let's look at an example. Find the value of theta if theta is equal to the inverse cosine of minus 0.2 in the range theta lies between 0 and 180 degrees. Well, we can find the principal value using a calculator, typing in cosine minus 1 of minus 0.2, and that gives an angle of 101.5 degrees. So the roots are plus or minus 101.5 degrees plus n times 360 degrees for any integer n. Now, some of these are minus 101.5 degrees, that's too small. 101.5 degrees, that lies in the range. Minus 101.5 degrees plus 360, which is 258.5 degrees, and that lies in the range. Or 101.5 degrees plus 360 degrees, which is equal to 461.5 degrees, which is too large. So the values of theta in the required range are 101.5 degrees and 258.5 degrees. Now the following is an exercise. Pause the video at this point and have a go yourself. When you've tried the questions, you can restart the video and I'll go through the answers. Okay, the important thing to remember in this exercise is when we're trying to find the inverse sine, we use our calculator to get the principal value theta naught. We then have two important values, theta naught and 180 minus theta naught. All other values are those two plus n times 360 degrees, where n is any integer. When we're trying to find the inverse cosine of an angle, then using the calculator we get the principal value theta naught, and the general solution is plus or minus theta naught plus n times 360 degrees, where n is any integer. And if we're trying to find the inverse tangent of x, then on our calculator we get the principal value theta naught, and the general solution is theta naught plus n times 180 degrees, where n is any integer. Well, in question 1 part A, we're asked to find the inverse tangent of 1.23. Now, if we do that on a calculator, we get the inverse tangent of 1.23 is 50.9 degrees, and this is our principal value. Now, if we subtract 180 degrees from it, we get minus 129.1, which is too small. If we add 180 degrees to the principal value, we get 230.9 degrees, which is in the right range. And if we have 50.9 degrees plus 2 times 180, that's too large, 410.9 degrees. So the two values that are in the range are 50.9 degrees and 230.9 degrees. In 1 part B, we're asked to find the inverse sine of 0.35. Well, if we find the principal value on the calculator, the inverse sine of 0.35 is 20.5 degrees. Now, the other important value will be 180 minus 20.5, which is 159.5 degrees. Now, that's also inside the range. However, if we go smaller, so we have 159.5 take away 360, that gives us minus 205, that's not in the range. And if we go larger, 20.5 plus 1 times 360, that's 380.5, and that's not in the range. So the two values that are in the range we want are 20.5 degrees and 159.5 degrees. Now in part C we're asked to find the inverse cosine of 0.28. So when we use our calculator we get 73.7 degrees, that's our principal value, and so the two values we're interested in are 73.7 and minus 73.7. Well, we can keep adding 360 degrees or subtracting 360 degrees, and we get a whole lot of different values. If we look through those, we see the only two that are in the range are 73.7 degrees and 286.3 degrees. In part D, we're asked to find the inverse sine of minus 0.4, which if we do that on a calculator is minus 23.6 degrees. That's our principal value. Now the other important value is 180 minus the principal value, which is 180 take away minus 23.6 degrees, or 180 plus 23.6 degrees, which is 203.6 degrees. So if we take those two values, and then onto each of them we add 360, we get the values minus 23.6, 203.6, 336.4, and 563.6. Now the only two that lie within the range are 203.6 degrees and 336.4 degrees. So those are our answers. In question 2 part A, we're asked to find the inverse cosine of minus 0.6 in the range 180 degrees to 540 degrees. Well, if we do that on a calculator, we get the answer 53.1 degrees, and this is our principal value. The other important value is minus 53.1 degrees, which is too small. So if we add on 360 degrees, we get 306.9 degrees and 413.1 degrees. And if we add on 2 times 360, we get 666.9 degrees, which is already too large. So the only two values that are in the range 180 to 540 are 306.9 degrees and 413.1 degrees. In part 2b, we're asked to find the inverse tangent of minus 0.85, and when we do that on the calculator we get a principal value of minus 40.4 degrees. And then we can keep adding 180 degrees to it, and the result is shown in the table. We see the only two values that are between 180 and 540 are 319.6 degrees and 499.6 degrees. In part C, we're asked to find the inverse sine of 0.45, and that gives us a principal value of 26.7 degrees. It also gives us an important value of 180 minus 26.7 degrees, which is 153.3 degrees. Now we can keep adding 360 to those two answers and get the table below, and we see the only two values that are in the range we want are 386.7 degrees and 513.3 degrees. In part D, we're asked to find the inverse sine of minus 0.45. On a calculator we get a principal value of minus 26.7 degrees, and the other important value is 180 minus 26.7 degrees, which is 180 plus 26.7 degrees, which is 206.7 degrees. Well, we can add 360 to those two answers and get the table below, and we see the only two values that are in the range are 206.7 degrees and 333.3 degrees. In question 3a, we're asked to find the inverse sine of minus 0.2 in the range minus 180 degrees to plus 180 degrees. Well, if we do that on a calculator, we get a principal value of minus 11.5 degrees. The other important value is 180 take away minus 11.5 degrees, which is 180 plus 11.5 degrees, or 191.5 degrees. So we have two values, minus 11.5 and 191.5, and if we subtract 360 degrees, we get minus 371.5 degrees and minus 168.5 degrees. So in the range we want, minus 180 to plus 180, the values are minus 11.5 degrees and minus 168.5 degrees. In part B, we want the inverse tangent of minus 2.5. Well, if we do that on a calculator, we get minus 68.2 degrees, and we can subtract or add 180 degrees to that, and we get the results in the table. We see that the only two values in the range minus 180 to 180 are minus 68.2 degrees and 111.8 degrees. In part C, we want the inverse cosine of minus 0.15. Well, the calculator gives minus 81.4 degrees, so we also want plus 81.4 degrees. Now, we can subtract 360 degrees from them, and we get the table below. In the table, we see that the only values in the range we want are minus 81.4 degrees and plus 81.4 degrees. In part D, we want the inverse sine of 0.15. When we do that on a calculator, we get 8.6 degrees, and if we take that away from 180, we get 171.4 degrees. Now, we can add or subtract 360 degrees from either of those, and we see the only numbers we want in the range are 8.6 degrees and 171.4 degrees.